Welcome to our lesson on understanding ratios. So hopefully you have this page in your notes. If you don't have it with you, you can just jot the information down on your own sheet of paper. But we're going to kind of talk about what is a ratio and kind of how to recognize them and find them. But a lot of it comes down to counting. It's really just counting how many of one thing to how many of something else. All right, so to begin with here, over on the left, it says a ratio is a relationship in which for every x of one quantity, there is y of another. So it really comes down to telling me how many of them there are. So there are three different ways to write it. We can write it with the word 2 in between it. We can write it with a colon in between it, or you can write it with a fraction bar. So we want to use the example of the pictures of above. There are 14 cat pictures and 17 dog pictures. We want to know the ratio of cats to dogs. So we put the number of cats first, 14, and we put the number of dogs second, 17. So the biggest thing is you have to make sure you put them in order. Since I talked about cats to dogs, we want the number for cats first and the number of dogs second. So it wants us to write it in three different ways. So we can write it with a colon. We can say 14 to 17, or we can do 14 over 17. But a ratio is just comparing how many of one thing to how many of something else. So over on the right, it says, use a ratio to compare the number of cats to the total number of pets. So we want cats to total number. Well, there are 14 cats, so 14 for cats. The total number is the cats plus the dogs, which gives us 31. So 14 to 31, or 14 to 31, or 14 over 31. Okay? So you're simply saying how many of one thing to how many of the other. Keep them in the appropriate order, in whatever order they asked. Okay? And then I always like to think of ratios as fractions because it helps remind me that fractions should always be simplified. So in this case, 14 over 7 or 14 over 31 can't be simplified, so we're good. But later on, we're going to watch carefully to see, hey, can I simplify this ratio down to its kind of simplified form or its most basic form? All right, bottom of the page. Now we're talking about turtles and frogs. So I know my picture is in color. I know in yours it's black and white, but you should still be able to tell kind of which ones are the frogs and which ones are the turtles. But it says, what's the ratio of frogs to turtles? So frogs first, turtles second. There are 7 frogs, so 7 goes first, to 5 turtles, 7 to 5. And I want you to get in the habit of writing it in all 3 ways because it kind of trains your brain on how to know, how to recognize it no matter which form it's given to you in a problem. Then it says, what is the ratio of turtles to total animals? Well, turtles comes first. We know that there are 5 turtles. For total animals, we want all of them, including the turtles. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a ratio of 5 turtles to 12 animals. 5 to 12. Okay? But that's really as basic as a ratio is. It's just comparing 2 quantities together. All right. So back of that page, we've got some practice problems. And these are all going to relate to the pictures at the top of the page. We've got 3 red, 2 blue, 6 yellow, and 4 green marbles. Okay? What we're going to do is we're going to create some different ratios comparing the different colors. But what we're going to have to be careful with is, remember what I said, we always want to write it in simplest form. So sometimes we're going to think about, okay, what was really going on here that got me to this simplest form? So the first one says, the following ratio statement reads, for every 1 red marble, there are blank yellow marbles. Well, you might be looking at it and go, well, there's not 1 red marble, there's 3 red marbles. Well, what it's doing is red to yellow was 3 to 6. But 3 to 6 can be simplified. Remember, they can each be divided by 3, and we get a ratio of 1 to 2, which basically means for every 1 red, there are 2 yellow. And then another 1 red goes with 2 yellow, and 1 red goes with 2 yellow. Okay, we split each of them up into 3 equal groups. Each group of red had 1 in it, each group of yellow had 2 in it. So for every red marble, there are 2 yellow marbles. Okay. All right, next one. A ratio that compares the yellow to the green. Well, there are 6 yellow to 4 green, but 6 to 4 can be simplified. Those can each be divided by 2, and I get 3 to 2. So we always want to be thinking about, can I simplify that ratio? Oh, kind of like a fraction. All right, next one says 3 to 4 is the ratio of red marbles to what kind of marbles? Well, 3 red, so I need 4 of something else. That would be green, because there are 4 green to 3 red. Next one, the following ratio statement reads, for every 1 blue, there are 2 whats? Well, if you look at blue, there's not just 1 of them. There's actually 2, which means they split it into 2 equal parts. So looking at the other options, if I were to split it into 2 equal parts, which one would have 2 marbles still in it? Well, if I were to split the green in half, I would have 2 and 2. So it must have been the green marbles that we are using, because our ratio would have been 2 to 4, which became 1 to 2. All right, bottom half of this page. But again, still referring back to those marbles up at the top. It says 3 over 2. So 3 of something to 2 of something represents the blank of red marbles to blue marbles. Well, 3 over 2 is just a ratio. Okay, it's comparing how many reds to how many blues. 4 to 15 is the ratio of green marbles. Well, there's 4 of those to what? Well, as I'm looking up there, none of those groups have 15 in it. But what if we look at all of them together? What if I did 3 reds plus 2 blues plus 6 yellows plus 4 greens? That gives me 15 total. So 4 to 15 is the ratio of green marbles to the total number of marbles. Okay. Next one's a little tricky, so I'm going to help us with this one. In the ratio of yellow marbles to blue marbles, 6 to 2, the quantities 6 and 2 are called terms. Those are just what we call each of the individual pieces. Okay. And then the last one is just kind of our vocabulary. It's what we've been talking about. A ratio compares one quantity to another quantity. Okay? It's comparing how many of one thing to how many of something else. Okay? That's all a ratio is just comparing two amounts. All right, last little part for our lesson today. So one way to do it is to draw out our different ways of showing things. 5 to 3, or 5 to 3, or 5/3. Okay, because this is the ratio of footballs to soccer balls is 5 to 3. But we can also use some pictures to help us kind of break things down. So one way to do that is with something called a bar diagram. So since there are 5 boxes of footballs to 3 boxes of soccer balls, they drew 5 boxes for footballs and 3 boxes for soccer balls. And they made each of the boxes the same size so we can kind of compare which one had more and how they compare with each other. But we want to use that same ratio, that same picture, to say, well, what if there were 100 footballs? So what if footballs were 100? Well, look at our diagram. It was broken up into 5 equal parts. Well, what's 100 divided by 5? Well, that gives me 20. So if I had 5 groups of 20, those would that would all add up to be my 100 total. Well, if each one of those is equal to 20, each of these down here is also equal to 20. me fix that one there. Since they're the same size boxes, there just happen to be 3 boxes instead of 5, but they're each equal to 20. So if I had 3 groups of 20 for soccer, that must have been 60 soccer balls. So I can use that ratio of 5 to 3 to help me even when there are bigger numbers involved. Okay? All right. And then the last is something called a double number line. It's just kind of a way of watching 2 different numbers kind of grow at the same pace and kind of seeing how they're going to compare with each other. So this one says, Chen can ride his bike 3 miles in 15 minutes. 3 miles in 15 minutes. So at this rate, how long will it take him to ride his bike 18 miles? So there are lots of different ways of tackling this one, but one way to do it visually is with a double number line. A double number line just allows that ratio to kind of continue to grow. So on the top, we're going to do miles. So 3 miles in 15 minutes. Well, if you went another 3 miles, so 6 miles, that would take him 30 minutes. Because every time he goes up 3 miles, it goes up 15 minutes. So think of it as he's kind of counting up by 3s here, and he's counting up by 15s here. So I just kind of keep counting as I go up. Okay. And the question was, how long would it take to go 18 miles? Well, at 18 miles, it would take 90 minutes. So 18 miles in 90 minutes. So what we're doing is we're kind of watching each one of them continue to grow at that same rate, kind of keeping them in pairs so we know how they match up with each other to see what other information we can come up with. 12 miles would be 60 minutes, or 9 miles would be 45 minutes. But the miles are growing at that rate of 3. The minutes are growing at that rate of 15, because that's our ratio. And we're kind of looking at where do they grow from there. So pause and try this one for yourself. And then hit play and see how we did with it. But kind of read the problem, think about how am I going to show that on my double number line, and then hit play and listen to me finish it up. All right, this one said, Chen's friend Alyssa can ride her bike 2 miles in 7 minutes. So that's our ratio. 2 miles to 7 minutes. We want to use our double number line to figure out how long would it take to go 10 miles. Well, I know it's 2 miles for 7 minutes. So 4 miles would be 14, and 6 miles would be 21. I'm just going up by 2 each time, and I'm going up by 7 each time. I'm counting by that ratio. So that would be 8 and 28, 10 and 35, 12 and 42. And the question said, how long would it take Alyssa to ride 10 miles? Well, I find my 10 miles, and I see what it was paired up with. It would take 35 miles, 35 minutes. Okay, so hopefully you have a little bit better idea of how ratios work and how to kind of use some different models to help us figure it out. Go ahead and hit stop, and then you are going to do a little bit of practice in your textbook.